Uh, okay. Yeah. Yeah. So thank you very much, everyone, for joining in. And today we are going to discuss building and evaluating a production-ready multi-agent system on Google Cloud. So I'm just going to change this to a slideshow. And this session is going to be a code lab whereby we are going to first talk about what is a multi-agent system. Then we would now put it into action whereby we would work on building a multi-agent system on Google Cloud. So the first thing is what is an AI agent? As usual, we pretty much have various definition for an AI agent. But typically, an AI agent is a service that talks to an AI model to achieve a specific task. So an AI agent is a service that talks to an AI model to achieve a specific task. And AI agents or agents in generally, they uses a combination of context and tools to achieve a specific goal. So for a multi-agent system, which means that we are combining multiple agents together at the same time, they sort of have a control flow, which means that there are different ways they can interact with one another. Here are some of the control flows that happens in a multi-agent system. The first one is the sequential models, which means that the agent waits for an intermediate result before he can begin his own process. So you can think about this like an assembly line or a bottling company. So in an assembly line, process A must be done before process B can happen. Just think about it like a bottled water company. When the bottled water is formed, then the bottled water moves to the next process. And maybe the bottled water is rinsed. Then after that, the bottle moves to another process. Then the bottle is filled with water. And after that, it is capped. And after that, it is packaged. So that's an example of a sequence. So agents could also work in a sequence whereby an agent is done, then it proceeds to the next agent, then it proceeds to the next one. The other one we have is parallel models. So this is a case whereby multiple agents works together at the same time, concurrently, to achieve a particular goal. So more often than not, in this case, we used to have an aggregator. And the work of the aggregator is to aggregate the response of each and every of the models and combine it into a single output. Another interesting control flow in a multi-agent system is the hierarchical routing. In this process, we have two sub process in this process. The first one is the loop agent, which means that the agent can go around a loop or can go around a circle until a particular condition is met. So if the condition is met, the loops break and proceed to the next task. But if the condition is not met, it keeps going around the loop. And also in this case, we can also set something we call maybe a maximum iteration so that we don't just keep running the loop indefinitely. Then another thing we have is conditional LLM agents. So in the conditional LLM agents, what's interesting there is that the agent must wait for the previous output. So the previous output sort of defines the path that the current agent is going to take. A good example is a flowchart. So in a flowchart, we have our decision box, and if it's a yes, it follows a path. If it's also a no, it follows a different path entirely. So that's what happens in conditional LLM agents. So let's talk about some of the communication protocols that AI agents use. As we all know, in traditional software engineering, there are some communication protocols that are defined for us, whereby for or just even in networking, we have some communication protocols like HTTP, SSH, IP, and a bunch of other communication protocol. So the same thing in AI agents when we have a multi-agent system whereby multiple agents are supposed to talk to one another. We also have their own communication protocol. The first one, and I think this is also the popular one, which is MCP, the Model Context Protocol framework for an AI agent to access tools that it does not own. So MCP is the foundation or the framework for an AI agent or for just a agent generally, an agent generally to access tool that it does not own. So the tool could be maybe a database or maybe a particular function to do a particular task. So
Sorry,
when an
Mustafa.
agent,
Oh, hi. Sorry,
yeah,
Mustafa, for interrupt you. We are unable
okay,
to see your stream, so you might to fix the streaming, maybe refresh the stage or rejoin and reshare again your slides because we're unable to see.
okay, yeah, thank you for that.
Thank you.
Um, okay, looks like it's good now. All right. So, just a recap of what MCP means, which give us the framework for AI agents to access tools that they do not own. And this tool could be a database, it could be a website, it could just be a function to do a particular thing. MCP sort of give us the foundation for AI agents to get that extra capabilities. And some people also define MCP in an interesting way, and they call it the USB-C for AI agents. So think about what you use a USB-C adapter for. If your computer need access to a printer, you could use a USB-C to give it access to a printer. If your computer need access to an extra screen, you could also use the USB-C adapter to make it accessible to an extra screen. So that's all the same thing the MCP framework does in the agentic world. So the next one we have is the agent-to-agent protocol, which is a way an agent can interact with if another agent. And the agent-to-agent protocol is powered by what we call an agent card. So this is an example of an agent card. An agent card is sort of a digital manifest of an agent or of an agent, yes, that enable us to know the capabilities of the agent, the skills of the agent, and also how you can authenticate to that particular agent. So if we go back to the previous slide, if agent A needs to talk to agent B through the agent to agent protocol, so we have the workflow agent. What the workflow agent will do is to first request for the agent card of all the agents, of all the other agents in the agent to agent server. So when it requests for the agent card, then it knows the capability of each and every agent. When it checks the capability of each and every agent, it can now decide to route tasks to the various agents in the server. Okay. So and the other one we have is the multi-agent interaction. So there are two ways agents can interact together in a multi-agent world. The first one is cooperative multi-agent system, which sort of means that all the agents comes together and they work alongside one another to achieve a specific goal. So more often than not, in this case, we always have what we call a synthesizer. The work of the synthesizer is to just make sure that all the agents are able to communicate with one another and bring about a complete solution. So you can think about this as maybe a group work, so or a group project. In a group project, every contributing member is supposed to come together and work towards the end goal. So in this case also, every agent in the loop works together to achieve the end goal. And we also have the competitive multi-agent system. In the competitive multi-agent system, each and every agent comes up with a complete solution on their own. So all the agents compete with one another, and each and every one of them individually produce a complete solution. So we can now have an evaluator that just select the best solution, or maybe in some advanced case, select the best two solution. So that's the difference between a cooperative multi-agent system and a competitive multi-agent system. So this is just to lay the groundwork for the code lab we'll be doing today. And depending on your use case, you can decide on the multi-agent interaction you want to use, or also you can also decide the control flow you want to use, or the communication protocol you want to use in your agentic system. All right. So the code lab would be doing this code lab. We want to build a multi-agent system, and we'll be doing it in. We want to create a cost creator. So we want to create a cost creator module, and to create this cost creator module, we would use multiple agents to build a cost creator module. So this is sort of what the end result would look like, and this is a sample of how the course creator works. Like when you want to learn a course or anything, you can just come here, put it in, and it's going to build it. And in the background, multiple agents work together to get about this solution. So I think we can begin now. And um, yes, so if you want to follow along, this is the link to the code lab. This is the link to the code lab. The requirement is to have a Google Cloud account with billing enabled, and you can get the link from here. I'm going to put the link in the chat. All right, so let's proceed. So here we are. This is the code lab we'll be working on today. And just to dive in, we are building a cost creator system, and we are using a multi-agent system. And under this multi-agent system, for this cost creator we want to build, we are going to use four sub-agents or four different agents. The first one, we'll call it a researcher agent. The second one, we'll call it a judge agent. The third one is the content builder agent. And the last one is the orchestrator agent. So we'll see how each and every one of them would work together to bring about the cost creator system. Okay, so this is the system design. So we'll have our front end, and from the front end, we have our orchestrator agent. The work of the orchestrator agent is to direct and control the state of all other sub agents. So such as our researcher, our judge, and our writer. And while we are building each of the agents, I'm also going to explain the kind of interactions or the kind of communication protocols or the control flows that happen between each and every of the agents. So I think we can proceed to our setup. So the first thing is we have a starter repo that contains all the instructions we are going to use. Some of them are already pre-done for us, and we just have to fill them as the lab goes. So the first thing is to clone our repo, and to clone this repo, we have to have an account with Google. We have to have an active GCP project. So this is the GCP project I'll be using today, and I'll be using a quick lab project. And the first thing we have to do, following the instruction. So this is the instruction. Following the instructions, we have to clone our repo. So to clone our repo, you just activate the Cloud Shell. I'll try to explain as much as possible as we go. So after activating the Cloud Shell will provision our Cloud Shell machine, and after that, we would connect to our Cloud Shell instance. So I think this is what we need to do. So we can clone the repo, and the repo is cloned now. So from our instruction, the next thing we need to do is to enable the required Google Cloud service. So you can copy this command and enable the required services, and it's going to enable our services for us. Okay, so this error is an harmless error. It's just talking about some access boundaries. So, but this is the result of our command, operation successful, and that means all the APIs that we want to install are enabled already. Okay, so the next thing we need to do is to sync the dependencies for this project. So through the UV sync, we'll just run the UV sync command here, and it's going to sync the dependencies that our project needs. So running the UV sync, and it's downloading all the dependencies. And all these dependencies, they were gotten from the repo that we just cloned. So here are my dependencies completed. So the next thing we need to do is to we need to save some of the things we would use in an environmental variable, so that when we want to call them, we can just call the variable, and it's going to just persist the value inside. So through this command, we are exporting our Google Cloud project into an environmental variable called Google_Cloud_project. The same thing for the location, and Google Gen AI use Vertex AI. Okay, so we can copy this command, then we can paste it here, and it's going to have our environmental variable. So if you want to confirm if any of them is done, we can just use the echo command to confirm this. Just going to remove this, and you should see my quick lab project. So this is my project ID. That saved it under this particular environmental variables. So I think all these things are pretty much basic. Then the next thing we need to do is to persist the environmental variables in our current shell through the source.env. And after that, I think we are done with the setup. The next thing we need to do is to start building our agent. So let's move to the interesting part. The first agent we are building is the researcher agent. And the researcher agent so the work of the researcher agent is to sort of wear the hat of the specialist, and just to make findings about a particular thing or just any topic that we want to learn. Don't forget that the end goal is to build a course creation model. So anything we want to learn, the work of the researcher is to make sure that we are able to learn it. So through the researcher is an example of an agent, and in this case is representing an agent. But the researcher needs access to a tool for it to make findings, which can be maybe a web search tool or a Google search tool. But natively, the researcher does not own that particular tool. So this is where we would use one of the communication protocol that we explained previously, which is MCP. So for the researcher to be able to have access to a web search tool, he has to use the MCP framework to talk to the web search tool. So this is where we are just trying to make sure that some of the things we've explained before, we are joining it together. So let's go ahead and build our researcher agent. So I'm going to grab this command with me. Then I can open my editor, and this is going to connect to my editor. So we have to wait till it persists here. The files is loading. Yeah. So we have so this is what we cloned from the repo, and we have our agent folder, and under the agent folder, we have all the individual agents we are building. So the content builder agent, the judge agent, the orchestrator agent, and the researcher agent. the first thing we need to do is to build our researcher agent. So when we go to our agent.py, so like I said, most of all these things are pre-written for us. We just have to complete it we just have to follow the steps and complete it along the line. So the model we'll be using here is the Gemini 3 Flash Preview model. And we are also using Google ADK, which is the Agent Development Kit. And Google ADK already has MCP inbuilt in the framework. So Google ADK has MCP inbuilt, and that's why from Google ADK.tools.google search tool, we are just importing the Google search tool, and it sort of uses MCP in the background. And the interesting part is when we are building our agents, we are pretty much just using simple English. So you can see we are building our researcher agent, and the core part of the researcher agent is here, which is that we are telling the model that you're an expert researcher. Your goal is to find comprehensive and accurate information on the user topic. Summarize your findings clearly. If you receive feedback that your research is insufficient, use the feedback to refine your next search. Do not output any function calls. Provide your research directly as text. So this is just the core engine of our researcher agent, and we've pretty much built it. So the next agent we are going to build, let's just keep following the instruction. The next agent we are going to build is our judge agent. And there's an interesting explanation here. So the interaction between the judge agent and the researcher. So you can think about this as a maybe a thesis. So when you're doing your thesis, you sort of have a supervisor, and your supervisor goes over your thesis, and it could also make corrections. So when the supervisor makes corrections, you're expected to work on those corrections and bring it back. So that's sort of the interaction between the researcher agent and the judge agent. The judge agent is supposed to evaluate the work of the researcher, see if it's viable and if it's correct. If it's fine with it, approve the work of the researcher. If it's not fine, if it's not fine, send it back to the researcher with some of the missing information, and for the researcher to work on it. So if you take a look at this closely, and I think some of us can guess in the chat what's the kind of interaction that would happen between the researcher and the judge. So if you guess correctly, it should be a loop agent. It should be a loop flow, or a loop control flow. So because the researcher and the researcher have to keep going to the judge until the judge approves the research. So if the judge does not approve the researcher has to what? Go back and also refine the research work and also push it back to the judge again. So the interaction between the researcher and the judge, it's a loop flow. And let's build our judge agent. So we just need to also grab this command line, and we go back to our editor. So the judge has a defined folder. We can click on the judge folder, and under the judge folder we have our agent.py. So we just need to paste this command here, and I'm going to just explain this. So what's happening here is that so if you look at it from the import, we imported Pydantic, which is supposed to give us a structured framework of how we want to a structured framework of how we want our output to be. So the Pydantic framework helps us to define this, which sort of means that if the judge is fine with the research, it should give a pass. But if the judge is not fine, it should return a fail. And if it's return a fail, it should also talk about some detailed feedback. It should give a detailed feedback on what is missing. But if it's a pass, it should just give a brief confirmation. So from the loop explanation, it is the pass that will break the loop and pushes it to the next flow. But if it's a failure or a fail, the loop skips working. So here is the part where we define our our judge agents, and also we are defining this in simple English. Yeah, a strict editor evaluates the research findings against the user original request. If the findings are missing key information, return status equals to fail. If they are comprehensive, return status equals to pass. As basic as that. So that's the core engine of our judge agent. And I think we are also done with building our judge agent. And let's move to the next task. So we can click on next. So before we proceed, I think we can test some of these flows and see if it actually works. So let's test our researcher agents and let's test our judge agent and see if they can do some basic research for us. So um, I'm going to access it through the ADK in my cloud shell format. So what I need to do is just to go back to my terminal. Likewise, you can also access a terminal from here. I'm just fine with this. So when we paste this command here, it's going to give us a user interactive model whereby we can ask some question from the researcher. And yeah, so let's wait for you to pop up. Yes, so we have our user module here and a sample question we can ask it because we are in the World Cup season. I think we should just do a question or do a research about the FIFA World Cup. Do a research on FIFA World Cup in 26. Let's see if it comes up with a research for us. Okay, so looks like it came up with a research and yeah, so let's keep so below is a comprehensive research summary covering the key aspect of this tournament. So I'm not going to read everything. I'm not just going to bore you, but this is just to show that the researcher works. So the researcher got a prompt and he invoked the Google search tool to the Google ADK format using MCP um, in the background. And it tells us that this is the first time the tournament is hosted by three nations, Canada, Mexico, and the United States. It also tells us the opening match, where the final match would come, the duration of the tournament. Also talk about the expanded format. This is the first time it's featuring 48 teams from the previous 32 teams or thereabouts. Okay, it also talks about the host cities and venues. So it sort of did a comprehensive research. Also talks about the slot allocation for the different nationalities or for the different region. Also talks about the qualification status and the unique features of the World Cup, and also the economic impact of the World Cup. So this is more than stating the obvious. So let's also evaluate the work of our judge. And I'm just going to terminate this part. I'm just going to terminate the researcher agent. Then we can talk to the judge agent and see if things are going fine. Okay. So the same way, we could also invoke the judge agent and we'll give the judge agent a a basic research and see what is going to return. So let's invoke the judge agent. So here we are, and so I'm just going to do something like topic. So using the same format, topic FIFA World Cup 2026. Then I'm going to say findings. Let me just say findings Mexico, US, and Canada, and also say something like maybe June. I think it runs from June 11 till July 19. So let's see if this basic information is good enough for the judge to pass this research. So just imagine you were given a task to find a research on the FIFA World Cup, and this is what you came back with, just these two sentences. And let's see if the judge is maybe magnanimous enough to pass this research, or if it's going to reject it. So, as all of you would have guessed, the judge was almost certain to fail this particular research because this research findings is just stating the obvious. So, like this particular one, you can see that it's not as comprehensive as the one that the agent came up with. So, what I just passed here was topic FIFA World Cup findings Mexico, USA, Canada, and just the timeline, which is too basic. I'm just sort of stating the obvious. And the judge was able to come out with a response that the findings are too brief for a major international event. Key missing information include the number of participating teams, the list of the 16 host cities across the three nations, and the location of the opening and final matches. So the beauty of this is that when we built our judge agent, we built it in a way whereby if it's going to reject the research, it should give it a detailed feedback on the missing information, and this is the detailed feedback. So why we are able to get a structured response like this is through the use of the pydantic framework. So you can see the response is in JSON and it's structured. We have the status and we have the feedback. So I think we can also terminate the judge and just continue building our agent. So we've tested some of the things we wanted to test. So let's proceed. The next agent, which is the third agent we are building here, is the content builder agent. And pretty much the work of the content builder is to make the research or the findings of the research in a suitable format or in a cost-friendly format. So which means that if you want to learn a course, I'm very sure most of us here would not want to learn a course through an essay, whereby you're just thrown in front of large amount of text and you just keep scrolling through. But typically if you want to learn a course, you sort of want the course to have an heading, to have subheadings, to have maybe bullet points and everything. So that's the work of the content builder. The content builder is to make the content of the research in this particular format. So I'm just going to grab this command and we'll just go ahead and build our content builder agent. So let's open our editor. This is the content builder agent, and under it we have our agent.py. So just going to paste this inside also. So similar to how we built our researcher agent, this is where we specify the core instruction of the content builder agent, which is you're an expert course creator, take the approved research findings and transform them into a well-structured, engaging course model. And we give it some formatting rules, maybe start with a main title, use H2 for section headings, bullet point and clear paragraph, and maintain a professional but engaging tone. So pretty much what you would want in a sample course creator. And all these things you can feel free to edit them to maybe you can add more rules or add more definition depending on when you are building your own agent. All right, so I think that's pretty much all for the content builder. So the content builder is also a very simple agent. And the next one, which is the last agent we are building today, is the orchestrator. And the orchestrator is really it's a really interesting agent because it does not do anything on its own. So it does not have maybe a specific task that it's supposed to do. The work of the orchestrator is majorly to sort of be the manager of the team and monitor the state at which each agent is at a particular time. So the orchestrator is able to know that anytime it gets a prompt, it's supposed to first route it towards the researcher. Then after the researcher is done, route it towards the judge. Then the loop flow happens between the researcher and the judge. When the judge eventually passes the research, then now pushes it to the content builder or the content writer agent. So that's the major work of the researcher. So it's not a specialist agent like the researcher, which his work is supposed to find information about a particular topic, or the judge, which his core work is to evaluate the findings of the researcher. And also we know the work of the content builder, which is to make it in a content friendly or in a cost creator friendly format. So this is the architecture we'll be using. We'll be using the agent to agent protocol, and for multiple agents. So from my previous explanation, when multiple agents talk to one another, when an agent wants to talk to another agent, we pretty much use the agent to agent framework. But when an agent wants to talk to a tool, a particular tool, we can use the MCP framework. So now agents are communicating with one another. So we have to use the agent to agent framework. And we'll see how we'd use everything while we are building the orchestrator. So let's grab the first command, and we have to go to our orchestrator folder and build our orchestrator. Also in the agent.py, we can just paste everything under it. So what's happening here, this is the first part. What's happening here is that we are defining the connection for the remote agents. So if you are following, you'd see that we have we are defining the process for the researcher here. After all, we define for the judge, then we also defined for the content builder. And another thing that you can also take note is that we have the agent card URL. And for my previous explanation about the agent to agent protocol or the agent to agent framework, I mentioned that it is powered by the agent card. So the agent card is what helps us to know the capabilities of a particular agent. So when we know the capability of that particular agent and also how we can authenticate to that particular agent, that's when we can now decide to route stacks to it. So if you look at this sample agent card, we have the name of the agent, which is the researcher. The agent card also tells us the agent card URL. It tells us the description of the agent, which is to gather information using Google search, and it tells us how we can also authenticate to it. And sometimes it also tells us the kind of outputs that the agent gives. So same thing for the judge and same thing for the content builder. So I think that's fine. Can proceed to the next stage. Okay, just going to click on next. So the next stage, and what we are defining in the next stage is the escalation checker. And just go back and be sure that I've done everything here. Okay, I think we are good. So the next one is the escalation checker. And the idea about the escalation checker is so that we have a process that kills the loop and a process that keeps the loop running. So, and as you know, every loop has a way that we are supposed to have a way to break the loop. So if the judge says pass, we want to exit the loop. And if the judge says fail, we want to keep the loop running. So that's the work of the escalation checker. The escalation checker is supposed to help us to get the information from the judge at every particular time and see if it's a pass. If it's a pass, kill the loop. If it's a fail, keep the loop running. Okay, and I think at some later step would set the maximum iteration. But let's keep going. So we have this here. I'm just paste the escalation checker, and pretty much this is the work of the escalation checker. If it's pass, break the loop. If it's a failure, keep the loop running. Okay. So the next thing we need to do from the instruction, it's next, which is the research loop. Which is the research loop is the I talked about this before, and I said the interaction between the researcher and the judge agent, it's a loop because it's sort of like a reversible flow. If the researcher is not if the judge is not fine, send it back to the researcher. So and under this command, we are using just going to paste it here and then explain it. So we grouped this particular two agents, the researcher and the judge, into the loop agents and also the escalation checker. The escalation checker is just supposed to listen to the result of the judge. So we grouped these three things or these two agents, researcher and judge, into a particular subagent. We combine them into a particular subagent. And the subagent we are calling it is the loop agent. And here we set our maximum iteration to be 3, which means that if the judge if the judge rejects the result of the researcher 3 times, so at the fourth time it's just going to throw an error and return an error for you. It's not just going to keep the loop running and keep consuming tokens. Like we all know, tokens are expensive. All right. So that's about this. Then the next thing we need to do, and that's pretty much the explanation here. Then we can go to next. Then the next thing we need to do is to tidy up the remainder of it. So we have our loop agent, and the loop agent ends with the judge. So we now have the writer agent and the orchestrator agent. So the kind of flow between this and this and also the loop agent is what we call sequential agents, which means that the loop agents, and when I say the loop agents now, I'm talking about the researcher and the judge. The loop agent must be done before the writer or the content builder agent can do anything. because if there are no content, if there are no approved content, there's no formatting you want to do to a blank sheet. So that's why it's a sequential agent. It has to wait for the response of the loop agent before the writer can picks up, and after the writer picks up, send it back to the orchestrator. So these are the work of the orchestrator to monitor the states and just sort of guide the flow between all the agents in this multi-agent system. So let's grab this command, then go back to our shell. We have the sequential agent here, and the sequential agent is just to work with the researcher loop or with the research loop and the content builder agent, and it happens in a sequence. All right. Okay, so looks like we are good, and we've built all our agents. So the next thing we need to do is to sort of maybe test our agent locally and see if it works. So if it works, then we can now decide to push it to Cloud One. So let's test our agent locally. And to do that, we just go back to our terminal and run this command here. So let's see. It's building. And when it's done, we'll be able to test our agent locally. And the way we are also the idea we are using here, we are sort of using a microservice architecture, which means that we are decoupling every agent from the other. So the researcher agent stands on his own. The judge also stands on his own. The content builder, and the same thing for orchestrator. And we now use the control flows to interact between one another, which sort of gives us the flexibility to redeploy the researcher agent. So we can decide to maybe make the researcher agent more smarter and redeploy it without affecting the judge or the other agents. So here we have, and this is the final one that we just need to check. And I'm just going to open it locally and for us to see looks to just see how it looks like. So this is it. We've built this, but this is still running locally. We've not deployed it. So let's test it. Let's say I want to learn um so, so just because we are in the World Cup season, just want to learn about being a professional footballer. Let's wait for it to come up. So you can see it's initializing our AI squad, and we have the researching, the fact checking, and the writing. So let's see what it comes up with. Still running. It could take a while. Yeah, I think it's done now. Okay, so we have our course on how to be a professional footballer, and the interesting thing is that the work of the researcher is to do this, and we also notice the work of the judge because this research is a bit comprehensive enough, and we also notice the work of the content builder, which is to make it in a course format. So we have the heading, which we said we should use H1, and for sectional heading to use H2. So you could see everything reflect here, and it's also using bullet points where possible. So it talks about the physical excellence and periodization, the technical mastery, the tactical intelligence, mental health and psychology, professionalism and lifestyle, and the football industry and career paths. And you also come up with an evaluation and certification section, and also the recommended reading section, which is really interesting. Okay, so we've seen that this particular what we are building actually works locally. So I think we can now deploy it to Cloud One. Okay, so let's move back to our Google Cloud Console. Then I'm just going to terminate this part. Okay, so terminated. Then we can proceed to the instruction. So this is some of the things if you want to test some of the individual agents. So I don't necessarily need to test the individual agents because I got the correct flow at once. But in case you maybe you notice some errors, you could you could use this to troubleshoot and maybe outline the agent that is not responding. So you could troubleshoot the researcher agent on its own, the judge agent on its own, the content builder, and the orchestrator to just know where the issue is. Okay, so let's deploy to Cloud One. Let's deploy to Cloud One. So based on my previous explanation of using a microservice architecture, whereby each and every agent is decoupled from the general flow. And for this, and also just to save our time, I'm going to run the three agents in parallel. And the three agents I can run at the moment are the researcher agent, the judge agent, and the content builder agent. I can't deploy the um I can't deploy the orchestrator agent yet. So the reason why we can't deploy the orchestrator agent yet is that for the orchestrator to work, it needs the agent card of the researcher, the judge, and the content builder. And until we have successfully deployed them, we cannot have their agent card. So that is why we can only do the three of them in parallel at first. Then we proceed to the other one. So what we are going to do is just run this command here, which is not necessary, but we can open some new shells in our cloud shell. Let's open some new tabs and also paste this here before we now deploy all the agents in parallel. So let's have this one also and paste this here. Okay. So the next thing we need to do is to grab our command. So I'm going to deploy the researcher in the first tab, deploy the judge in the second one, and the context builder in the third. So let's deploy the researcher here. And like I said, this error is harmless. So I'm just going to say yes here. Okay, so it's saying something about constraints. Oh yeah, sorry. So because I'm using a quick lab project ID, I'm unable to deploy to and so the default region for this my quick lab project ID is to deploy it in the US Central one. And this command, the command here is telling us to deploy in US West one. So if you are doing this on your own, you wouldn't experience this error. So what I need to do is just to change this to US Central one. Okay. So I'm just going to come to my so I opened the Colab notebook already so that I can use it to change. So I'm going to change the region to US Central one. So after changing the region to US Central one, then I can deploy it once again. So I've changed the region to US Central one here. Then click on enter. So these are the harmless notifications. But we should see it's building. So it's building and it's loading already. So while that is working, let's grab the next command and deploy our judge. So let's move to the collab here. Paste this. So I'm just going to change this to US Central 1. So if you are doing this from your own account, you shouldn't experience any issues. So this is still running. So we can deploy the judge here. And just going to wait for it's deploying already. It's deploying, it's working. So we can monitor this. This is still working. Also monitor the second one. This is also still working. So let's deploy the last of the three agents, which is the content builder. Just grab this command from here, then go to my collab, paste this. Also change this to US Central 1. Then move to this part and also deploy this and wait for it to start deploying. So these are the harmless error. And yeah, deploying. It's deploying. So we can take a look at the first one and see if it's done. Okay, it's not done, but it's creating the revision already. Can also monitor the second one and the third one. So it pretty much takes like 2 to 3 minutes for each and every one of them to deploy. But the good thing is that we are doing them simultaneously, so we should be done um, anytime soon. If you have questions, you can keep them in the chat, and I'm going to get to them at the end. So here we have, this is our researcher, and we have our researcher URL already. So our researcher agent has been successfully deployed. You can just check the status of the other two. So this is still working, and this is also still working. So we have to wait for it to be done. Okay. Yeah. So our judge is also done. Then we have our judge here active. So let's wait for our content builder, and I think it'll be done in no time. Okay, so I got a deployment error on the judge. So what I'm going to do is just to run it again to say something about quota. Interesting. So let's deploy it once again. Let's deploy it once again, and hopefully it's done this time around. And while that is going on, the next instruction we need to do is to capture the URL of all our agents. So we'll capture the URL, we'll save them to an environmental variable for the orchestrator agent to use. So we'll save them into the researcher URL, judge URL, and the content builder URL. So I'm going to copy this, but I won't run it until we are done with the last agent. And hopefully we are able to deploy this now. Saying some things about memory, but hopefully it works now. Still deploying. Okay. So it's setting the IAM policy now, then creating the revision. Okay. While it's on this stage, let's go to our collab and just edit the region for this one before we run it. So like I said, in your own case, you may not need to do all this, but the lab I'm using has some restriction on the region. So I have to deploy in US Central 1. So this is still not done, but let's wait for it. Okay, we are good. So we can see it here now serving 100% of traffic. And this is the URL of our content builder agents. So we can actually terminate all these two tabs now. I'm just still going to leave it. But everything we need to do, we can do it from the first shell now. So let's paste the command, the one we just do, so that we can get the URL of the researcher, the judge, and the content builder. And it should come up with it soon. So here, this is the researcher, this is the URL of the researcher. And for the judge, we have the URL, the content builder, we also have the URL. So we are good. And the next thing we need to do is to deploy the orchestrator. So I'm just going to grab this command, and I have to change the region to US Central 1 once again. So I'm just going to change this to US Central 1 and paste it here and click on enter. So it's going to deploy my orchestrator for me. And if you are curious enough and you want to see all the deployments. You can search for Cloud Run just from the you can start from Cloud Run, and in Cloud Run we are going to see everything that we've deployed. So if you take a look at it, we have the content builder, the researcher, and the judge. So these are the agents that we've deployed. And if when the orchestrator is done, when we refresh it, we'll also see the orchestrator here. So the idea is to use the microservice architecture so that we can work on them without them affecting one another. Okay, so let's just wait for our orchestrator to be also done. And after the orchestrator is done, we'll also grab the URL, then we'll deploy our front end. So the front end will give us the interface whereby we can we can ask or we can decide to learn any course form. Okay. Don't forget each deployment takes like 2 to 3 minutes. Let's just wait till this guy is done. Okay, so setting the IAM policy and creating the revisions. Okay. So I think it's going to be done in sub 1 minute now. Hopefully we don't run into any error again. Okay, almost done. Yeah, so it's done. The orchestrator is done. If I refresh this part now, we should be able to see the orchestrator also. So if I bring this thing down, we can see our orchestrator, which was just deployed just now. So that's the beauty of using Cloud One. Okay, so the next thing we need to do is to grab the URL of the orchestrator, and from this command, I'm going to just persist the URL into this environmental variable orchestrator URL. Okay, so why it's throwing an error is because I did not change the location once again. So let me change this to central one, and just going to run it again. Then I should grab my orchestrator URL. So here's my orchestrator URL. And the final thing for today or for this code lab is to deploy the front end. So let's deploy the front end. I also need to change the region to essential one. Okay. So just going to paste this here. And it's going to deploy the front end. Yeah, so also working. So by the way, we are almost at the end of this lab. I know it's top of the hour already. We are almost at the end. If you have any question, just drop it in the chat. This is the last deployment, and thereafter, I'm going to also share the link to the chat so that we all can also try to create our course from it. So it's going to be done in 2 to 3 minutes. Moving close, so it should be done in sub 1 minute. Okay, yes, finally. So if we also So if we also refresh this thing, we should see our next deployment, which is the course creator. So this is the course creator, and this one houses the front end. So from here, you can view the metrics on it, and this is the URL we just need to view our course creator from. And yeah, so this is a live deployment, and don't let us maybe learn about football again. Maybe you want to learn about linear algebra. Or no, not linear algebra. What can we learn about? Hmm, Just so hard to think about what to learn about, but let me try data engineering. So if you want to learn about data engineering, let's see what the the team is able to do for us using our multi-agent framework. It's working. Okay, so you can see it's researching, then moves to the end. So we have our data engineering course duration 12 to 16 weeks, self-paced or guided, depending on the one you need to know, basic programming language, Python, and a fundamental understanding of what data is. Yeah, so data engineering really needs domain knowledge. I agree. So talks about the foundations of data engineering, the language of data, SQL and Python, really important. Data modeling and architecture talks about the Kimball, star schema, snowflake schema, a whole lot of things. The modern data stack ingestion, also big data and pipeline orchestration and stream processing, data quality testing and observability, cloud infrastructure and DevOps. And we have GCP here, BigQuery pops up, and some other ones. Yeah, so it also gives you a capstone project. Students must build a complete pipeline that does this. So, and also, another thing to take note is that the responses are non-deterministic. So, which means that if you also try to learn, if you also try to put data engineering here, you would get a correct information, but you may not necessarily get this word for word. Okay, so that's about that, and I think we are good to go. I just need to grab this URL, and so after that, I think that's pretty much everything about the code lab. So the next thing is just to summarize what we've learned. So the idea was to use a microservice architecture, and you also use a multi-agent interaction system, and we had a task. The task was to build a course creator, but we broke it down into multiple agents: the researcher agent, the judge agent, the content builder agent, and the orchestrator agent. And every all of them work together to deliver the final solution. And the other thing is that we talked about some of the control flows that agents use, such as sequential flow, the parallel flow, the loop flow, and also the conditional LLM flow. We also talk about some of the communication protocols, MCP, A2A. So, and all these frameworks now. So at MCP was developed by Anthropic. The A2A was developed by Google, and I think all of them they've open sourced those particular framework, and it's now managed by the Linux Foundation. So so most of the things we did here are actually model agnostic. If you if you decide you don't want to use a Gemini model, you could swap another model, and you would also get the same information as in almost a similar format. So I think that's everything for now. Thank you very much for staying through. And I think if there are any questions, happy to take them. Okay, so I'm just going to paste the link here. Sorry, I almost forgot. So you can also try to learn, maybe use the course creator course to do some things, but I'm going to close it down soon. So I think you can just try to use it and while it sits. Okay. Um, Yeah, thank you very much, everyone, and see you on Discord.